directions. Parking's not great, but you can find it.
All right. Welcome back from snack break, everybody. So it's always awkward when the first vice president is the presenter, because then who introduces them? So I got the honor tonight. So Jonathan, Kade, and I arrived in the club together in the end of 2006. We are observing partners and astronomy buddies. And Jonathan became fascinated with Venus when the transit of Venus occurred in 2012 and delved into that. Once the transit was over, and won't be occurring again in our lifetime, the interest remained. And so he's going to tell us more than probably anybody knows about the missions to Venus.
All right, so today we're going to talk about our sister planet, Venus, and all of the trips of exploration that humankind has taken to it. So Mars is what everybody talks about. Obviously this year we've been talking about the moon too, but everyone's excited about Mars, and Mars is also getting all of the funding as far as actual exploration goes. There's a whole cloud of robots on the surface of Mars, surrounding Mars, on their way to Mars. But Venus is pretty cool too, and maybe there's more going on there than you might expect. So Venus has played a special role in the history of mankind's discovery of the cosmos. So when Galileo wrote his letters on sunspots, he used the phasing of Venus and its changes in size as additional strong support for the Copernican system. So it has told us a lot about where the Earth is in the solar system from the earliest times that we were seriously discussing it. It disproved the Ptolemaic universe, and basically it gave us measuring the transits of Venus allowed us to actually get a sense for how far the distances in the solar system were. Prior to using the transit of Venus to calculate the distance from the Earth to the Sun, we knew approximately how far the planets were from each other, but we didn't know what the base unit of measurement is, the distance of the Earth to the Sun, and thus the scale of the solar system. And from Vesto Slipher forward, in the 1920s, the spectroscopy that we've done on Venus during Venus transits, just looking at Venus in the sky, trying to figure out what its atmosphere was like, has prepared us for doing exoplanet spectroscopy and figuring out what's on other worlds outside of our solar system. So it's been very impactful so far in the history of our discovery of the cosmos, and we have spent a lot more time close up and personal with it than you might expect. Unfortunately, it might tell us something about our future. So things went terribly wrong on Venus, as we'll talk about in a second, but it may have started out very similar to Earth. So I'd like to start out by comparing approximately to scale a view of Venus from Magellan, as well as Earth from Apollo 17. Obviously this is taken with radar and then mapped to visual, but very similar in size, but a lot of differences that you can see there. The radius of Venus is very close, 0.95% of that of Earth. The surface area, thus, is 90% of that of Earth. The volume is a little less than 90%. The mass is about 80% of Earth's. The surface gravity is actually pretty similar. As long as you could stand there, you would feel pretty much at home until you melt. So the surface temperature is 864 degrees Fahrenheit. Not so similar. So here's the atmospheric composition of Venus. it is 96.5% carbon dioxide in the atmosphere, 3.5% nitrogen, and then essentially very difficult to measure stuff. Comparing that to Earth, you can kind of see things have gone terribly awry. We're at 0.4%, they're at 96.5%. So, yeah, we have a lot of nitrogen. There's very little atmospheric nitrogen left on Venus. So, even though we're sister planets, there's a lot of differences between the two at this point. So, now that we have talked about the similarities and differences of our two planets, would anyone care to hazard a guess as to how many missions humankind has sent to Venus so far?
I think you sent like 3 of them.
Does that include the failures?
That includes all failures. I will take either failures, all including failures, or just the successes. You said 4?
I said 4.
60.
60. 10.
7.
7. All right. So far, as of today, there are 43.
Wow.
So 60, Bob is closest at 60.
This
And-
is Price is Right rules.
Yep. And so I may be cheating a little bit. From Bob's definition, probably includes the ones that just use Venus as an atmospheric booster, or as a gravitational booster to get them other places. I'm including the ones that actually did science on Venus. So, all right. So, of the 43, 27 have been successful. Now, there's a reason that you might not have heard about some of the ones that were successful. And that is because a lot of them were from the Soviet Union. And not only did the Soviet Union not do a lot of advertising in the US at the time, during the space race and after the space race was over. Actually, a lot of this was done after the space race. But we just didn't really want to hear about it, and we didn't have access to the data in a lot of cases. The US actually has had 10 successful missions to Venus. So far, the European Space Agency has only had 1, and JAXA has had 2 at the present time. So there is ample blank space here, and we'll talk a little bit about that at the end of the presentation. JAXA is the Japanese space agency, who, you know, the Hayabusa 2 mission has been extremely successful, but pretty much all of their major missions before that ran into some serious difficulties, and the Venus mission is not an exception. So, yes sir?
Would you like a cough drop?
I would love one, thank you. So, the Soviet Union started trying to send probes to Venus almost as soon as Sputnik was successful. So, Tyazdeli Sputnik was the first attempt to send it there. This is a mock-up of a Venera craft. Actually, I think it's at the Smithsonian Air and Space Museum. Venera 1, the US sent Mariner 1, and one of the competing Russian launch concerns sent one just codenamed 2MV1. All of these failed. It turns out that the Russian space agency in the early 1960s, as you will hear at Jim Shedlowski's talk at Cranbrook in September, put all of their eggs in a basket called Korolev, and his bureau was called the OKB. And they built all of these. They had gotten Sputnik into space, they had gotten Laika into space, they had gotten Yuri Gagarin into space, but they had a really hard time building stuff that worked. Venera actually did get to Venus. It flew by Venus. All of the other ones either blew up on the pad or just didn't work once they got into space. So,
Didn't one land on Venus and took a picture of the ground?
there's still
We're getting there.
40 minutes in this talk. So,
At least all, I thought.
So, the first successful visit, which you don't hear about very often, was Mariner 2. So this was one one of the cases where the US actually did beat Russia in the space race. And for some reason, people don't talk about it, simply because, I guess, nobody cares about Venus except for me. And the date of this successful mission was August 27th, 1962. So when it passed by, it recorded the temperature for the first time, measuring the temperature at 500 degrees Celsius, 900 Fahrenheit. So that was the only science it could really do. At the time, remote sensing was a very young field.
Any
and it
pictures?
was-
Any pictures?
No pictures. Literally all they did was do infrared measurement of the cloud tops, essentially, or just below the cloud tops. So Russia kept trying and trying and trying. Zond just means probe. Essentially, they wouldn't give them real names until they actually got into space. So all these MV1, MV2, if they had gotten into space, they would have been classified as Venera craft. But since they blew up or never turned on in Earth orbit, they just got left as their code names. So despite the successful flyby, they just kept trying to send probes, and they actually started building landers very early. Zond 1 and Venera 2 both succeeded in flying by Venus. Neither of them was alive when they flew by Venus, but, you know, almost there. Venera 3 actually dropped a lander onto the surface of Venus, but the lander died on entry and crash landed and didn't collect any data. In the fall of 1965, after this, Sergei Korolev gets told by his bosses in the Politburo that this thing isn't working out and he needs to focus on working on the moon mission. You know, they need to focus their efforts on beating the US to the moon. And so he transfers off the entire Venus program to his semi-rivals organization, who take a very serious approach to the problem. So the Lavochkin Bureau, when they first took over, with Luna and Luna 3. So basically, Sergei Korolev's group had succeeded with Luna 1 and Luna 2, but as far as the other interplanetary probes had gone, they hadn't done so well. So the Lavochkin Bureau took over with Venera 4, I think, and actually got it to drop a lander. What they found out in their analysis of Venera 3 was that they had never done G-force testing with the probes, and so the gravitational force of entry had actually killed a key subsystem, and so they were able to actually start solving those problems, and then began a string of really remarkable successes. So Venera 4 did the first chemical analysis of Venus's atmosphere, finding that there was a 13-to-1 carbon dioxide to nitrogen ratio. Took the first temperature and pressure readings from inside the atmosphere, and it proved there could not be any liquid water on the surface. So this mission was the first successful in situ study of another planet. So it's a really remarkable achievement. The US sent Mariner 5. It was actually destined for, originally it was the backup for Mariner 4, which went to Mars. But since Mariner 4 worked and everything was good, they decided to retool it for Venus. This spacecraft observed the atmospheric pressure from above and measured the temperature more precisely as 527 degrees Celsius. It also looked for something like the Van Allen belts. They wanted to find out if Venus had a magnetic field similar to that of Earth's. And this probe proved that Venus had no significant magnetic field. It's 1% the strength of Earth's. So this mission was kind of where the US's interest in Venus really flagged, because obviously it's not livable at all, there's no magnetic fields, it's very dissimilar to Earth. Before that, a lot of people still were entertaining ideas that something could be similar to Earth and that we could do something with it. So this was both a very successful scientific mission and also not so great for US investment in going to Venus. Venera V actually parachuted down Venera 5 and 6. So the Soviets always sent 2, and they had similar mission parameters, and the idea is that they would enter at different places and take measurements at different places on the planet. It also saved them money on testing things, because they were testing things in bulk, sort of. The Venera 5 had a photometer that actually measured the visual density of Venus's atmosphere. So they figured out that, they started to figure out that Venus had empty space underneath the clouds. They confirmed the Venera 4 pressure and density readings, did more chemical analysis, and each of these survived for almost an hour inside Venus's atmosphere. They also brought a bas relief of Vladimir Lenin to the surface of Venus, which promptly melted, which is a good thing to do. So, the first man-made spacecraft that we know actually made it to the surface, operational, was Venera 7. So we have moved along to 1970, so the space race is over, right? The US got to the moon, the Russian moon program is sort of in a state of arrested decay and in the process of beginning to be dismantled, and Sergei Korolev is dead, and things generally have not gone great for the cosmonauts. So the Soviet Union decides to focus their energy into doing interplanetary probes. Venera 7 landed, transmitted from the surface, so in that regard it was a success. What it was not such a success was that it landed on its side, and at first they thought it was a total dud, and it was only when they really examined the tapes that they found signals that were about 1/100th the strength that they had been expecting, because the antenna wasn't oriented correctly. So the only new data that it sent back was that the surface temperature was 887 degrees Fahrenheit, so that it got warmer as you got closer to the surface. So Venera 8, the sister craft to Venera 7, was the first totally successful landing. It landed, the antenna was pointed right. They found out that this is where we started understanding that there are 3 different significant layers in Venus's clouds. Basically that there are different layers with different chemical compositions and different transparencies and different wind speeds. So they measured wind speeds of less than 1 kilometer a second below 10 kilometers, and they basically got an idea of what it looks like in Venus's clouds. So it landed, it was 495 kilograms, almost a little over half a ton. Actually, I guess 2/3 of a ton. And after landing, continued to send data back for 50 minutes. So it confirmed the earlier probe's recording of the surface temperature, and in general, just proved that they could land something, have it live for a while, and collect a lot of data on the way down. Yes, Dr. Parker?
When you say it sent data successfully, I assume you mean all the way directly back to Earth, not
Yes.
to some orbiting
Right.
spacecraft.
Right. Yeah, although that approach would come later as well. So, all right, so basically all these Cosmos missions would have been Venera missions had they succeeded. So they were still failing. So Cosmos 167 was part of Venera 4, the unsuccessful part, and 359 was a third sibling of. 359 was Venera 7s, and 482 was Venera 8s. So actually 7 and 8 weren't siblings, but very similar in design. So, Mariner 10, which was on its way to Mercury, took the first great close-ups of what Venus looks like from orbit. So this is the first time that we actually have photography happening at Venus, and the first time, the second time after Mars that we have photography happening on another world. So you may have seen some of these photos before that are still pretty widely popular. But didn't do too much science other than just taking the close-up photography. And it passed by Venus this close in order to get a gravitational boost to get it into a flyby of Mercury. So, now the Soviets have successfully landed, operated on the surface for a while. They've had photometers. They have not had photography equipment on the surface. So they decide to massively, so there's still the same core here. You can kind of see the same core shape, but they keep adding on more powerful antennas. They keep adding on stuff to keep it from tipping over on landing, and so they're getting more and more sophisticated. But what Venera 9 and Venera 10 in 1975 add for the first time is a camera. So these are the first photos taken on Venus's surface. So unfortunately, the camera, it's awesome that it's panoramic, but it also is pointed almost straight down, so you can't see any of the mountains up here. So this is the one photo taken from Venera 9. This is the one photo taken from Venera 10. This is Venera in Cyrillic. So these are super cool photos, not often seen. A lot of people don't know that these missions even happen. So a man named Don P. Mitchell, who is an amateur amateur planetary science historian, was able to get the raw transmissions from these crafts and reprocess them in HD. So he was able to take this, including these garbled sections, which turned out to be just bit encoding errors, and turn them into this, and then he was able to sort of patch in, using Photoshop, the missing areas here to produce an almost HD view of what Venera 9 actually saw. So if you compare this kind of garbled photocopy or fax quality photo with what he was able to produce, it's really impressive. So his website is mentallandscape.com. I highly recommend checking it out. He has all kinds of stuff about the Soviet space programs and the interplanetary exploration programs that are worth checking out. He reprocessed the Venera 10 photos the same way. So you can see some really interesting geology here. You can see there's lots of different outcroppings of different textures of rock and different chemical compositions. So there's definitely some really interesting geology down on the Venusian surface. So you wouldn't want to visit, but you could send a probe. So the US finally gets back into the game with a pair of crafts that is specifically intended to explore Venus. The Pioneer Venus Orbiter had the mission of orbiting around the planet and taking a radar map of everything on the surface. So I think we got about 90% of the surface of Venus mapped with this mission. This mission is one of the most successful missions in NASA's history, or in space exploration's history. The Hubble has been very successful, right? It's been going since 1992. This craft lasted from 1978 until 1992. So this was still transmitting data back to us in 1992 when Hubble got put into orbit. So just to put that in perspective, this was a spectacularly successful mission. So this is essentially Pioneer 12. The multi-probe was Pioneer 13. So they worked in tandem. The orbiter relayed signals back to Earth. The multi-probe, actually, there was essentially a mothership that we sent that had 4 other landers. So the mothership went, basically we put the orbiter into orbit, then we sent the multi-probe after it. The multi-probe let out all the child probes, which all landed at different places, which I'll talk about in a second. And then the multi-probe itself then went into the atmosphere and acted as a 5th one. So it was a really interesting design. So essentially, the way, if you look at the surface of Venus, you'll notice this dark line here. Anybody know what that is? The Terminator. So this line was of interest to our scientists. We wanted to see what the difference was in temperature, pressure, and just atmospheric dynamics between the dark side of Venus and the sunlit side. So what we did was we put one child probe solidly into the dark area, one in the light area, one in the northern hemisphere near the Terminator, one in the southern hemisphere near the Terminator, and then the mothership right in the middle. And so by actually doing all of those at the same time, and then the mothership did ion mass and neutral mass spectroscopy too on the way down. So we got really precise ideas of what chemicals were in each layer of the cloud banks. So each probe took about 45 minutes to get to the surface. They weren't expected to last on the surface, but even though this wasn't intended to be a lander mission, one of the Terminator probes actually landed on the surface and transmitted data for an hour and a half after landing, even though it wasn't designed for that. So it was a very surprisingly successful mission.
Question.
And yes, sir.
Did they all go down with parachutes?
I believe they had little parachutes, and because of the atmosphere, the thickness, you don't need that much of a parachute to slow you down a little bit. And the temperature is going to kill you almost as fast as the impact will. So,
So did they learn, what did they learn from those 4 probes?
so basically they got really detailed analyses of what so essentially they measured wind speeds at different places near the Terminator. They got extremely precise information about what each level of the cloud tops, what chemicals they consisted of, what the wind speeds in them were, and essentially we got our first really good idea of what the real atmospheric dynamics. Like, we had a really rough idea before. We knew generally the temperature, we knew something about how thick the clouds were. We had some idea of what the general chemicals were, but this measured it very precisely.
So the hot and the cold, the Terminator.
Yeah, so it actually didn't make that much of a difference. I think the difference in temperatures was less than 50 degrees Celsius. So it was, it's really, it's about 900 degrees no matter where you are. It's not a place you want to be, even on the dark side. So the Soviets continued to try. In 1978, around the same time, they launched the 11 and 12 Venera probes. Both of them made it. Both of them collected important data. They were trying to take color photographs. And it turned out that the lens caps got stuck on both of them. Oh. So they landed on the surface, they collected useful data, but the lens caps wouldn't open, so they couldn't get their color photographs. But they did actually do some really cool science on the way down. So they observed gamma ray bursts. They got the first evidence that there was thunder and lightning happening in the Venusian atmosphere. And they also measured carbon monoxide at the surface, which was a little bit surprising. So just a little while later, they tried again. They replaced the the lens cover mechanism with a new one, and this time they succeeded in landing and taking the first high-res color photographs. So these are black and white. Again, these are reconstructed by Don P. Mitchell. And what he has done is actually, these also had, I'll show you what they looked like. So he's actually overlaid the color. They had never published the color photographs, and he was able to get the raw data and reconstruct the color photographs. So, and these are reconstructions with the black and white. So it's, you know, seeing what really got me interested in this subject in the first place was finding his website and seeing these reconstructions of what the surface of Venus looks like. You know, it's an alien landscape, it's a very inhospitable landscape, but so is Mars, and this is a very different place to Mars, obviously. It's just got its own weather cycles, it's got its own scars, and it's really an interesting, unexplored place, very close to home. So, here's some more color photos. So, you can see a little bit of red. So, they were pretty good on the landers at this point. They had gotten color photos. I really wish they had gotten, you know, a wider angle than that, but they were happy with their results and also wanted to quit spending so much money on the on landers that got photos like that. Also, this was a time when the Soviet Union was really pinching pennies. So what they sent instead was high-res mapping, radar mapping craft. So 16 and 15 used 8-centimeter band side-looking radar. So this is their radar dish. So this is their dish for relaying data back to the Earth, and then this is what's observing the planet. So they were actually launched together, they were orbiting together, and together they were inserted into orbit 1 day apart with orbital planes shifted by an angle of 4 degrees relative to each other. So if Venera 15 missed an area, they could reorient 16 to pick it up immediately afterwards. So this is the super high resolution view that they got. And again, this is another one reconstructed by Don Mitchell. So they were able to measure, so this is the North Pole of Venus at the center, and they were able to measure down to 30 degrees north latitude over 8 months. So this is about 25% of the surface of the planet mapped out into a circle. So this was Venera. This is Vega. I don't know if you've ever heard of this. This is at the Smithsonian Air and Space Museum. So Vega is actually short for Venera, and the GA is Kade. So this craft was a dual-purpose craft. What it did was drop balloons into Venus's atmosphere, and then the craft carried on to rendezvous with Halley's Comet and observe Halley's Comet close up. So basically, Vega 1 had, actually they did have landers too. So Vega 1's lander had some problems, and they were trying to do seismography on the surface with the lander part, and it got activated by high winds in the atmosphere, and they did the seismography experiments at 25 kilometers above the ground. So seismology doesn't work 25 kilometers above the ground. So, but the mass spectrometer on the craft was able to return data. The Vega balloon was able, each balloon was able to cover roughly 30% of the circumference of the planet. So these two balloons together covered almost 2/3 of the circumference of Venus. So that's a pretty cool achievement. Like, I don't think a lot of people know that we have been doing cloud top studies of Venus since 1984.
Don't you mean the area of Venus rather than circumference?
No, so because this is just a balloon, so it's just going in a straight line.
Oh.
So it's really, what they wanted to do is measure the wind speeds over a long period of time, figure out what the,
Oh, yeah.
how turbulent it was and how the large scale wind systems moved. So. All right, and then finally, the US's biggest contribution so far to our exploration of Venus, the Magellan Probe. So the Magellan Probe is the one that you have on your Venus globes at home. The Magellan Probe is the one that you always see. So it mapped 100% of the surface of Venus in high definition, in radar, and produced this wonderfully psychedelic map. So this is showing chemical composition. Magellan got into orbit in 1989, so it was there. Magellan was in orbit at the same time that the Pioneer Venus orbiter was still working, and it lasted until 1994. So this was orbiting and doing its science mission for 5 years, and produced some really remarkable, because it was doing altimetry measurements too. We got tremendously detailed ideas of the shapes of all of the mountains. Now we know what all the crevasses on the surface of Venus look like. So this was definitely a huge accomplishment for our space program. So that was the last glorious mission for a while. And then we start using Venus as a gravity assist flyby. Galileo uses it on its way to Jupiter. Cassini uses it on its way to Saturn. Messenger uses it twice. Well, Cassini used it twice. Messenger uses it twice on its way to Mercury. And this is pretty much all we got. Messenger took really pretty black and white pictures, and then it was gone. So thankfully, the European Space Agency, which previously hadn't really existed, finally decided to turn their sights to Venus and sent Venus Express there. So the intent of Venus Express was to do high-res observing of Venus's atmosphere over long periods of time. So it actually reused the design and parts from the Mars Express mission and from the Rosetta probe. It confirmed the Venera 11 observations of lightning and thunder in the atmosphere, and discovered that Venus has more lightning happening than Earth does, which is not something you really think of either. It discovered that there is an ozone layer in Venus's atmosphere, which had previously gone undiscovered, in area in the upper atmosphere where dry ice can form, and that at the south pole of Venus, there's a stable polar vortex that's always there. And most importantly, it actually took the first evidence that Venus had previously had water on it. So the only current mission, so this craft lasted for, I think, 2 or 3 years. What we currently have at Venus is Japan's mission Akatsuki. And so if you're familiar with the saga of the Japanese Hayabusa probe to go collect samples from an asteroid, it had one thing go wrong after another, and finally got 5 grains of asteroid powder back to the Earth. So it was disaster turning into something approaching triumph. And Akatsuki is no different. So Akatsuki tried to do orbital insertion in 2010. You see that this is 2015 through present. The engine didn't turn on. And so they just plowed right past Venus and into solar orbit. And so they sort of watched this happen in horror and said, well, what can we do? And they actually were afraid to ever use this engine that failed to turn on again. So they ended up using attitude control thrusters to push it into a widening orbit that finally got captured by Venus and went into Venus orbit. On top of that, so they finally get into orbit in 2015. They have had to use their attitude control thrusters for orbital insertion and now can't do as much exploration as they wanted to do. And then on top of that, in 2016, they noticed that they were having huge power spikes. And it turned out that the huge power spikes were being caused by infrared cameras that were a big part of their science mission. So they had to permanently turn the infrared cameras off. So this thing is still limping along. Everything has gone wrong, but it got into this weird orbit and has taken some really cool pictures. I think this is an animation. Let's see if I can get it to play. Anyway, so they produced a movie, you can see this online, of Venus's Nightside. So this is in infrared before they shut the cameras down. And this is the heat. These are the heat waves rippling from the day side through the night side. They observed in 4 hours the clouds moved by about 10 degrees over the 360-degree circumference of the planet. So it's really cool. You see the clouds forming and changing, and it really gives an insight into what's happening inside the atmosphere. It also measured this large standing wave in the upper atmosphere of Venus. So clouds normally whip along at about 100 meters a second, but this standing wave sort of mimicked what happens on Earth when clouds are going by a tall mountain. So it's kind of unknown still what exactly was causing this effect. And essentially they got a lot more information about the wind speeds near the equator versus in the polar regions. So, as part of the Akatsuki package, there was a student space probe, a CubeSat called Shannon, and it was the first student-built spacecraft of any kind to pass through the Earth's Van Allen belts, but it failed to turn on and didn't transmit. Now we're back to the chopped liver years. So the Parker Solar Probe is using Venus many, many times to get into solar orbit, a close solar orbit here, and it's not doing anything on Venus at all. So this is an artist's rendition of it flying past Venus and not caring. But, well, okay, took that picture of Venus. All right, Bepi Columbo is a new mission to Mercury, sponsored by the European Space Agency, and it also used Venus primarily as a gravitational system. But it's not fair to call it chopped liver because Bepi Columbo actually has some really cool science goals for Venus. Part of the science goals for Venus are to calibrate their instruments for use on Mercury, but I'm not going to hold it against them. So they're doing temperature and density profiles at the poles, chemical composition, global circulation, trying to figure out what's going on underneath the surface of the planet, which is not something that we've done enough of, and then figuring out interactions in the outer Venus atmosphere between the sun and Venus's atmosphere. So some really cool science goals, and I'm really looking forward to seeing what happens as it gets there for the first time next year. Going into the future, India is in the process of launching a new craft called Shukrayan 1. It's planned to launch somewhere between 2023 and 2025. They have So after the Chandrayaan-2 mission is done, they're going to, or sorry, Mangalyaan is the one going to Mars. When Mangalyaan-2 goes to Mars, this will be the next one up after that. So they're actually working with France directly, so the French are probably going to put some science packages on this, not through the European Space Agency. The Russians have not quite given up on Venus yet. I don't know if you've heard of Venera D, but they've been talking about it. Right now, it's planning to launch in either 2026 or 2031. It has been in planning for about 15 years. Whether or not it's actually funded and whether or not it'll actually ever happen is still very much up in the air. So the D in Venera D stands for Dolgozhivujaya, which means long lasting. So the idea is they want to survive for at least a day on the surface. So, which would be almost an order of magnitude improvement over previous records. So it's going to be really interesting to see if this thing ever happens.
Pretty long lasting on Earth so far.
Yeah, that's true. Very long lasting on Earth. So, what is NASA doing? This photo was taken very close to us. This photo is from the High Temperature Electronics Testing Lab at the John Glenn Research Center in Ohio, just a little bit southwest of Sandusky, I believe. So this is the Glenn's Extreme Environments Rig gear. This photo was taken on July 13th, 2017. So they did an 80-day test at Venus surface conditions and then cooled the experiment for 2 weeks and proved that they were able to make electronics that would survive on Venus for an extremely long duration period of time. They didn't have these electronics energized at the time, which is the other problem you have, but at least they survived. So there's a lot of people, primarily at the Glenn Research Center in Ohio is where all of NASA's serious Venus work is happening right now. So they have produced proposals for a cloud top drone that would ride on the cloud tops. They have designed a land sailing rover. It's really easy to have a rover. It's very hard to have any electronics on it. But what is interesting is that despite all of this Glenn Research Center stuff going on, right now the most active project on Venus going on at NASA is coming out of Pasadena from JPL. And it is a Steampunk Rover. So the idea is to have an entirely mechanical rover without any electronics on it whatsoever. It is going to use a steam engine. It is going to have radar. It's going to have a mechanical computer, like George Boole's earliest computers in the 19th century. And it's going to have, basically, it will transmit data up to the surface by having the mechanical computer construct different radar reflector patterns mechanically, and then they will beam a radar at it and beam it back. I don't know exactly what kind of science they're going to be able to do with that, but there are some very smart people working on it. The gentleman who proposed this is named Jonathan Sauter, who is a mechatronics engineer at JPL, and he's been working on it since 2015, and it's actually still an active project as of now.
What kind of transmission rates would they be hoping to achieve with?
Extremely low. Like, I don't know, like, can you do any kind of chemical analysis that is purely mechanical? I don't know. That's a great question. I wouldn't say this is a heavily funded project. This is a project that is getting probably maybe a couple tens of thousands of dollars thrown at it a year. So they're paying somebody for a month out of their year to work on this idea. But what's also interesting is that it's designed so that it can work at almost any orientation. So if it gets knocked over, it can still keep running. So that's a pretty neat design. And so on that note, I wanted to over there. So I wanted to play this video for you of Magellan, of the map that Magellan took of Venus's surface features. So it's fairly low resolution. It was produced by NASA a fairly long time ago. It would be really nice to start doing some missions there and answering more questions about what exactly happened on Venus in the past.
Are these mountains? How tall are they?
So Venus is comparatively stunted. I don't know exactly the scale, but it's not the gigantic mountains that you see on Mars. I believe all the mountains are shorter than, say, the Everests.
They can't be as high as on Mars because the gravity is 1/3 on Mars and it's
Fair.
9/10 on Venus. So it's got to be comparable to Earth.
I think even shorter than Earth's too.
Okay.
So.
What mountains they do have, they're supposedly looking like they have snow on them, but it's not snow, it's like melted lead that comes down.
That sounds.
Okay.
It is, that's what they say.
That sounds unfortunate.
Yeah.
So there's, I was hoping to show a video of this, but if you search for, what is it called? Automaton Rover for Extreme Environments or Venus Clockwork Rover on YouTube, they have put up a rendering that they did in 2018 of what this would look like. So it's a pretty cool thing. All right, that's about it for me. Are there any questions? Any other questions?
What is that white area?
So these are like the lowlands.
It almost looks like volcanic floor or something on the other side.
I mean, Venus had water on it. So I don't know for sure if the topography that we see today was created by water. I don't know if that question has been answered.
So the Russians said that there was no.
Well, there's no water now, but there had been water in the past. So all of the water has been decomposed and has formed carbon dioxide.
I don't think you can see through the clouds anyhow, so that's probably all cloud.
No, this was done with radar. So basically what they did with Magellan was they did radar mapping, high definition radar mapping of the planet's surface, and then they mapped that. They did chemical analysis of it, and they also used the color photos taken from the Russian probes as a way of calibrating the colors. Also, the general color scheme is also informed by the fact that the atmosphere has sulfur in it and kind of smells like rotten eggs. Ken?
One of the things that's noticed is that there is virtually no cratering because of the weathering. Is that what they say?
Yeah, so you don't really see craters on the surface of Venus the way that you do on planets that have gone through. Yeah, even we still have craters that are in pretty good shape. And on Venus, like looking at Venus, like there's a crater there, and that's a really massive one. And everything else looks volcanic, like even that looks volcanic. So it's really, compared to Mars, compared to Earth, there's a lot less evidence of impacts. Yes, sir, John?
Any active volcanoes are spotted or not?
No, Venus is dead. Like the core is solid, it doesn't have a magnetic field, it doesn't have any, so there is some residual seismological activity, but there aren't any active geological processes like there are on Earth or Enceladus.
That radar mapping looks a lot like the photograph of Io.
Yeah, it does.
And
Although Io is much colder and a much better place to visit. If you have to choose, definitely go with Io.
Visually,
yeah. Ken?
The rotation of Venus is longer than its revolution period. I know that.
Yeah. So Venus's clouds go around in I think Venus's clouds go around in about 18 hours.
Really? That's very accurate.
Venus's day lasts 230, 240
The day is.
Earth days.
226.
The day lasts,
243.
well, the day lasts 280 Earth days.
I thought it was
So
23.
the day on Venus lasts for longer than the year on Venus lasts. And on top of all of that, Venus is going backwards. So Venus is actually rotating backwards. So all of this is pretty strong evidence that something really terrible happened in Venus's history. So Venus rotates retrograde with regard to its orbit compared to every other planet in the solar system. So the idea is that probably something impacted it, slowed it down, and actually reversed it. But right now there aren't great models of that. Diane?
Well, I was just gonna ask, is there any consensus on whether or not Venus and Mercury were the bad things that happened to one another?
There is pretty strong consensus that I have seen that Venus and Mercury both look like the outcome of a train wreck. Like, Mercury is a planet of metal that doesn't have a crust, it's all core. Venus has all this going on, it's backwards and has been through
They
a lot
ever
of
talk about
trauma.
gravitational locking with those two?
And well, it's actually Venus's for whatever reason, Venus is in revolutionary resonance with Earth. So when Earth and Venus line up, the same side of Venus is always facing Earth. There doesn't seem to be any reason for that, but it's weird. So it is surprising.
But what's the?
But right now there doesn't seem to be, from what I can tell, nobody is very confident in the idea that the train wreck of Mercury and the train wreck of Venus have anything to do with each other. So it kind of seems like Occam's razor, but well, I think Mike, you had a question?
It's mostly a lava planet or surface, right? Lava features, I think.
Yeah, well, yeah, and just melting, John.
Using Venus or any planet for gravity assist, I'm trying to understand. The spacecraft starts going faster as it approaches Venus as the gravity pulls it in.
Mm-hmm.
But then as the spacecraft passes Venus, the gravity should slow it down, so there should be no net effect. So how does it speed it up by going by?
Well, it really depends on the angle of your trajectory. So
you can gravity assist by a planet two different ways. One will speed you up, one will
Right.
slow you down.
yeah.
Well,
so
tell me how it can speed me up, since I
because-
speed it up on the approach and
because
then slow it down on the
The
passage.
time it takes you to come in is different than the time it takes you to leave, and there's an exchange of angular momentum. The way it was explained to me was you can think about it like an elastic collision. You take some away from Venus.
Regular words.
Oh, don't worry about it.
Dr. Martin.
The way you gain speed is, you're right, if Venus held still, when you came in you would speed up, when you went by, after you went by you would slow down. But Venus is moving, so it kind of drags the probe with it for a little while. That's where you gain the speed. I have a question.
Yes, sir.
So, I mean, I haven't followed this much detail on the Venus story, but if the story is that Venus once had liquid water on it, then it was obviously a lot cooler.
Mm-hmm.
Now, Venus is a mostly carbon dioxide
97% carbon
atmosphere
dioxide.
planet, and it's real hot and dense in its atmosphere. What caused the change?
That is the several billion-dollar question. Yes. Right now, there are lots of models for how you would do that, but there isn't general agreement on which model is closest to reality, or even how long ago it happened. A lot of it could be that the collision event that it went through was some kind of precipitating thing. It could be that was unrelated and happened long before. It seems to me that a collision event like that would have pulverized the planet like it did with Earth, and I don't know. But it's definitely the question that we should be really interested in finding out the answer to for our own good. Another interesting thing is that the traditional definition of habitable zones around stars includes Venus and excludes Earth. So I think that traditional guideline for the habitable zone might be a little bit off. So. Ken?
Do you think the pressure of the 90 bar atmosphere is as detrimental as the temperature, or?
Oh, well, definitely both have killed probes in the past. But I think we have gotten better at designing equipment that operates under pressure or at ways of diffusing pressure than we have about the continuous subjection to the temperature combined with the super corrosive sulfuric acid atmosphere. Like, everything is bad. Like, it's really bad. Mark?
You ever do any observing of Venus, and have you ever heard of anybody observing albedo features in the visual wavelengths?
So basically anything outside the, well, so basically seeing different brightnesses in the part that's lit by the sun. I would say one of my observing dreams is to see the crescent, the super crescent Venus. Because Venus has such a thick atmosphere, you can get
I had a marker? Oh, I put it away.
so on, basically, if I can use this as Venus, you can,
It look like the letter C.
yeah, so on the moon, right, like you see a crescent like this, or a crescent like this, or a crescent like this. But on Venus, you can see, so if this is the planet's surface, I can't draw circles, I'm sorry, you can see a crescent that looks like this, because the light is being transmitted around the planet by the atmosphere. So you can see a crescent that is almost a complete circle. So I've never seen quite that. And in fact, in historical astronomy, if you look at observations by Babylonian astronomers, the goddess Ishtar is associated with Venus, and one of the things is the horns of Ishtar, and people have speculated that they were actually able to visually see that. I don't think optics allow for that, but like I don't think your eyes can see that much. Like on Jupiter, you can see Jupiter is a disk under the, if you have super good eyesight, but I don't know if you can see that much detail on Venus. It's a matter of some controversy. But I've seen Venus at a very, pretty close to that. It's a pretty cool thing to see.
So that obviously has to occur when Venus is very close to the sun, right?
Right, yeah, so when in early evening or, just after the sun sets or just before the sun rises. Dale?
I'm pretty sure I remember reading in Sky and Telescope a decade or a decade and a half ago that some well-equipped amateur astronomer claimed that he had seen striations of some kind in the atmosphere.
I think I remember
using near-infrared filters. With a silicon photodetector, you could see a little ways into the infrared. And if you filter out the visible, then you're able to see a little bit into the clouds. And you could see some differentiations, so he claimed.
I recall that story. I haven't heard of anyone else doing that, but maybe people just don't care about Venus. So
maybe we need to buy one of those filters.
that would be something for Stargate. I'm sorry, was there another question? All right. Thank you. Go look at Venus. When it's back.
Can Venus cast its own shadow?
Yes.
Oh, yeah.
Venus can cast a shadow on Earth.
Yeah.
Yeah. Was that, yes. Yeah, so if Venus is up in the sky and everything is dark around you except Venus, you can see a shadow from Venus, and you can actually do long exposure photography.
Yeah, Marty Coons has done stuff with Venus shadows at Stargate.